Now we're going to look at different properties of quadrilaterals. And this is the unit that had a lot of different things that we had to remember. And we started looking at parallelograms. So in the first example, one of the properties of parallelograms that we learned is that opposite sides of a parallelogram are congruent, which means that I can set them equal to each other. So 8x minus 5 equals 3x plus 20. And when I solve that, I get 5x equals 25, and x equals 5. The next property we looked at was that the diagonals of a parallelogram bisect each other. So that means this diagonal is split in half by the other. So 11 equals 3x minus 1. And conversely, the 11 3x minus 1 diagonal cuts in half or bisects the other one. So 5y equals 15. And then I can solve this. So the first one would be 12 equals 3x, so x equals 4. And next, y equals 3. So that dealt with sides and diagonals. We also looked at the angles. And in a parallelogram, opposite angles are congruent. So 10x is equal to 11x minus 8, or 100 is equal to 10y. However, it's also true that consecutive angles are supplementary, aka I could also solve 10x plus 100 equals 180 and get the same answer. So it's really whichever I want to do. In both cases, I'm going to get x equals 8 or x equals 8 when I solve, and then y equals 10. So we can use that opposite angles are congruent or consecutive angles are supplementary. After we studied parallelograms, we looked at a special parallelogram, which was a rectangle. The definition of a rectangle that makes it different from a parallelogram is that it's a parallelogram that has all right angles. So anything I give you with that is going to be 90 degrees total. But it is still true that the diagonals bisect each other. The other thing is that the diagonals of a rectangle are congruent. So this, what red is equal to the green. And what effectively happens is that then you get that all of the piecey parts of my diagonals are congruent. So in this case, x would be equal to 10. The other problem that we had on this particular topic, and I'm going to erase some of my markings, had to do with finding these angles that you see labeled here. Okay. So with this, we want to use the fact that I am making a 90-degree angle. So that means if that is 53, then this angle needs to be 37. And then since those little sides were the same, you really just made a little baby isosceles triangle. So that means that z is also 37. And then I can kind of keep doing this. You know, I call it the domino method. And that means that this is also 53. So then w is 53. So then y is 37. Okay, and then I also asked you one time to find, like, say, this angle. It's not marked on this, but let's say we wanted to find that. Then I would do, okay, both of my base angles are 37. So 37 times 2 is going to be 74. And then we have a triangle, so 180 minus 74 is going to give me 106. So this random angle they didn't ask you for is 106. So the two things we added with rectangles are that you have all right angles and that the diagonals are congruent. I'm going to actually go down to the rhombus. So a rhombus is a parallelogram where all the sides are congruent. All the sides are congruent, are the same. So it's asking for x and y. Those are both sides, but they don't give me another side to set them equal to. So what we want to do is use a different property to get a side. And that is that in a rhombus, diagonals are perpendicular. They make a right angle. So if I have a side of 5 and a side of 12, then that means my hypotenuse is 13. It's a special right triangle, 5, 12, 13. Okay? Another nice thing with rhombi is that the diagonals are bisecting the angles. So once I find one of these angles, I can see what the other ones are. So I know this is a 90-degree angle, so I can find this angle they didn't ask me about by doing 90 plus 65 plus the angle I don't know equals 180. So the angle I don't know right there is 25 degrees, which means z equals 25. And then I could go around and do a really long roundabout way to find that w is also 25. But notice it's not all the angles because I had that 65 over there. The short way to realize that is we have a rhombus is still a parallelogram. So if I have what z equals, we have alternate interior angles going on here. Remember my zigzag? Whee! Okay. So let's talk about square. A square combines the properties of a rhombus and a rectangle. So I have the 90 degrees and congruent diagonals from a rectangle, and then I have that the diagonals bisect the angles, and that all the sides are congruent from the rhombus, and that the diagonals are perpendicular. So the diagonals being perpendicular will tell me what they want to know what y is. So y is going to be 90 degrees. Now, in a square, my angle is 90 degrees, but it's also a rhombus, which means that the diagonal is bisecting the angles. So if I know that those two angles have to be the same, and they add to 90 degrees, that means this angle x is always 45 degrees in a square. And so from there, we can use that fact and this side length of 4 to find z. So I am going to draw this separately, very badly, like usual. Okay, so I want to know what z is. If this is 4. Well, we just said that these angles are always 45, and that makes a nice little 45, 45, 90 triangle. So 45, 45, 90, x, x, x root 2. And this gave me my hypotenuse, aka across from the 90, is 4. So going forward, we multiply by square root of 2. So to go back, we're going to divide by square root 2. So 4 divided by square root of 2. We need to rationalize. And when I rationalize that, we are going to get square root of 2 over square root of 2. So 4 root 2 over 2, which would be just 2 square root 2. So z is equal to 2 root 2. Now the short way was just to divide by 2 and multiply by square root 2 at the end. Remember, it was my shortcut. But when all else fails, just rationalize the denominator. After those, we looked at some things that weren't parallelograms, such as kites and trapezoids. So in a kite, one thing that we want to know is that two of my angles, opposite angles, are congruent and two aren't. So the two that are the ones that are connecting the short side and long side. So in this case, this is going to be 125. Now, why is that helpful? It's helpful because I know that all of the angles in a quadrilateral need to add to 360. So 13y plus 125 plus 125 plus 9y equals 360. So 22y plus 250 equals 360. So 22y equals 110. So y equals 5. Other properties of kites are that the diagonals intersect at a 90-degree angle, so they're making little baby right triangles, and that the long diagonal bisects the shorter diagonal. So in this diagram, 15 is equal to 2x minus 7, so 22 equals 2x, and x equals 11. We can also find the length of y by thinking of this like a little right triangle, and we could do Pythagorean theorem. So 8 squared plus 15 squared equals c squared. So c equals 17, aka y equals 17. We looked at a bunch of stuff with trapezoids. So remember, a trapezoid means you have one pair of parallel sides. And I'm going to do the problem on the right first. This is specifically an isosceles trapezoid. So in an isosceles trapezoid, that means that you have a pair of sides, the non-parallel sides, which are congruent to each other. So say, for instance, TP is 5. That means that RA is also 5. Their other property is that their base angles are congruent. Their base angles are congruent. So let's see. If I have that this angle, the little angle is 20, then that means the corresponding angle in the other part is 20, and that this bottom one is 35. And let's try to answer some questions. So TPA would be this whole thing, so that's going to give me 55. PTR. Okay, so now what we want to do is use the fact that those two sides are parallel, which means that the one we just found, the 55, is supplementary to the angle I'm asking about, PTR. So that means 180 minus 55, which is going to give me 125. ZRA, and then PZA. I'm going to find PZA first. Let me see if I can clean up my diagram a little bit though. Alright. So we have this little isosceles triangle going on right here. How do I know it's isosceles? Because I have the same little base angles right there. Alright. So I'm going to try to find PZA, and that's making a triangle right here. So I know 35 plus 35 plus my angle equals 180. So that means that angle I care about is going to be 110 degrees. So the last thing that I want to do is find ZRA, which is this one kind of at the top. So there's a couple ways to do it. Since I just found PZA, I'm going to do it this way. I'm going to look at this whole line, and if this angle is 110, then that means supplementary is this one would be 70. I'm going to draw my triangle bigger over here. So this is 70 by the supplement. They gave me that this is 20, and then I can find by, let's call that y, 70 plus 20 plus y equals 180, so y equals 90. Another thing we talked about with trapezoids was finding the median. So the formula for the median was 1/2 B1 plus B2, which now should be kind of familiar because it's really the same as the area formula, except for it's missing the height. So the median in this problem is 9, so 9 equals 1/2 B1, let's call it x, plus B2 is 13. So 9 equals 1/2 x plus 13 over 2. And then we can subtract that. And y'all have calculators, which is awesome. I'm going to call that 6.5 to make my life happy. So I minus that and I get 2.5 equals 1/2 x. And then to get rid of the 1/2, we're going to multiply by 2. Yes, if you know how to do it, it is way easier to, at this step here, multiply by 2 on both sides. Would be a lot easier, but some of us may not have seen that. Okay, the other thing we talked about, this is when you did your big coordinate geometry project, and this is where you used proofs. So when we wanted to bisect, see if things bisected, we used the midpoint. If we wanted to show that they were congruent, we used either distance formula or Pythagorean theorem, mostly Pythagorean theorem. To show they're parallel, we found the slope and we said that the slopes were the same, and perpendicular meant that they were opposite reciprocal slopes. There we go.